know something, believe it or not. What's that? All right, let's try this again. It's not a circle, nor is it a square. It's a triangle. How many degrees are inside of a triangle? 180 degrees, okay? There's always 180 degrees on the inside of a triangle, all right? Now, do we know it's a square? Do we know it's a rectangle? We don't know. All we know is it's got 4 sides, right? Does it say they're 90? But if I do this, how many triangles fit in it? 2. Now, you're not wrong, but here's the deal. We're going to talk about what are called non-overlapping triangles. What that means is that they just don't overlap. Because if I put in the other diagonal, you're right, I'd have more triangles. You could continue on and on, but now these triangles start to overlap each other. So now I'm not worried about what's called overlapping. So you have 2 triangles at 180 each, which means how many degrees are inside of it? 6. Okay. Excuse me. Five-sided figure is called a what? It's a pentagon. Okay. You guys are going to have to know your names of things. Okay. If you do that, you have 3 of them. If you only had paper and a calculator, that you could do this correctly without trying to do the numbers wrong in your head. I know, right? Go figure. So how many sides is that? How many sides does the pentagon have? 5. So the number of sides was 5. How many triangles fit into it? 3 of them. So you take 3 times the 180, gives you how many total degrees are inside of that then? 40. Okay. What's a 6-sided figure called? It's hexagon. That's not a stop sign. Oh. The hexagon has 6 sides. And you draw this one out. How many triangles fit inside? How many non-overlapping triangles fit inside of a hexagon? 4. Which means how many degrees do you have? Double 360. 720. Seven sides. There are 2 names for a 7. There's a septagon, very good. The other one's called a heptagon. There are 2 names, guys. There's 2 names. Some textbooks, some worksheets call it a heptagon or a septagon. Heptagon or septagon means the same thing, with 7 sides. Like I was saying, they're all only the ones that are named that go up through 12 sides, and we'll talk about all of those. You guys have to know all those names. It's not, like I said, it's not like you've never done them before. So you get 1, 2, 3, 4, and 5. 1, 2, 3, 4, 5 triangles fit inside of the septagon that has 7 sides. Okay. So then you would do 5 times 180 to figure out the sum of the interior. This is what we're doing here, guys. Figure out what is the sum of the interior angles of a polygon. Okay. Sum of the interior, that's the words we're using. What was the 8-sided figure called again? The octagon, which is the stop sign And then how many triangles can fit inside of this? One, two, three, four, five, six. Do you sense a pattern yet? Yep. Yep. That's exactly right. So we have, I gotta finish, we're gonna finish out the name. Do you remember what 9 sides called? Nope. It's called a nonagon. Close. It's called a nonagon. Yeah. Who is it? Oh, come back later. Thank you very much. So 9 sides is called the nonagon. You know what 10 sides called? Close. Decagon. The answer is no. How many years is a decade? Seriously? A decade is 10 years.
What's a millennium?
A century would be 100. No. That would be a dozen. All right, what's the 11 gon called? Or sorry, what's the 11 side one called? It's not an 11. Don't draw it because they're awful. Just say it's 9 sides. Another white. 11 sides. It's not called an octagon. I'm making it up. 11-sided one is called an 11 gon. No, it's not. 12-sided is the last one that has a name. The 12-sided is the one that is the last one that has a name. Then everything else is just whatever number it is. So 12 is called a dodecagon. Okay. Everything else, if it's got 14 sides, it's called a 14 gon. If it's got 73 sides, it's called a 73 gon. And so on and so on. Okay. The only ones that have names: triangle, quadrilateral, pentagon, hexagon, septagon, or heptagon, whatever you want to call it, octagon, nonagon, decagon, dodecagon. There's only 9 of them that have names. Everything else is just whatever number of sides it is with the word, with the letters gon after it. Okay? And it works like that. Now, like you guys were saying, what we're working with today is this thing called the sum of the interior angles in a polygon. It's always equal to n minus 2 times 180, where n is the number of sides. So the sum of the interior angles in a polygon is always number of sides minus 2 times 180. Like I said, I'm pretty sure you've seen this before. Sum of the interior angles n minus 2 times 180. Super, super, super easy. Not terrible. So if I say, what is the sum of the interior in a 34 gon? Times what? Right. So it would be 34 minus 2 times 180. And you literally press some buttons. What was it? 5,760 degrees. It's that. That's what we're doing. Sum of the interior. Sum of the interior. Okay. Now, when we work with these, like we just said, sum of the interior. Now, when you're working with these things, and you know, bear with me for a second here, my computer crashed this morning. I have to reopen up some PDF files. Depending upon what information you're given, you might have to work backwards. Oops, sorry about that. We'll get there. So if the sum of the interior equals 3,240, how many sides does it have? That's all it is. What happens here is that we're going to be working forwards and backwards with these equations. Hold on. We know the formula for the sum of the interior. The sum of the interior is n minus 2 times 180. Okay? So the sum of the interior, n minus 2 times 180. Well, if the sum is 3240, work backwards. First thing you're going to do is divide by 180. Just solving for x. Work backwards. 3240 divided by 180. 18. 18 equals n minus 2. Now what do you do? Add what? And you get? I knew you meant you get the sides, yes. That is correct. Okay. It is really easy stuff. It's knowing what are you working with, what's it asking you to find. Okay. What are you working with, what's it asking you to find? Yes, sir. No. Don't draw those. They're awful. I want to try to draw a 20-sided figure. Okay. You don't want to draw those. Yes. No. Especially anything after like 8 sides. Anything after that just gets to be stupid. I don't mean like bad, but it's just awful. Nobody wants to draw that stuff. Nobody wants to draw that. All right. Now, to go with this, then we start talking about what's called a regular polygon. We got plenty. Remember what a regular polygon is? What was a regular polygon? We talked about it before. What's that? Close. Regular polygon. Regular polygons have all sides congruent and all angles. What are the regular polygons that we've worked with? Equilateral triangles. Equilateral triangles have all sides congruent, all angles congruent. What are all the angles in an equilateral triangle? 60. Okay. You've worked with that. What's a regular polygon that has 4 sides? Square. Square. A square is a 4-sided figure with all sides equal and all angles there. Okay. All squares are rectangles. Rectangles are squares. Okay. So what happens here is that if we go back to the idea, let's look at the pentagon again. If this is a regular pentagon, that means all 5 sides are the same, and all 5 angles are the same. If I wanted to figure out what each individual angle would equal, what would you do? Divide what? No. How do you find the sum of all 5 of those angles? No, well, yeah. Well, if I have a 5-sided figure, how do you find the sum of the interior? Okay. And then what? Uh-huh. So in this example, you have to find the sum of the interior. Oops. Would equal 5 minus 3 times 180. Okay. You do that first. And then if you're trying to figure out what each individual angle equals, well, we multiply this out, you're going to get what, 540? How many angles are there? 5. I'm sorry, I did 5 minus 2 in my head, it should have been 5 minus. I was thinking 5 minus 2 and it was 3. I just accidentally wrote it 3. So what's 540 divided by 5? 108. Each individual angle in a pentagon, if it's regular, would be 108. Okay. That's how we do these things. And the measure of an angle in a regular polygon is always n minus 2 times 180 divided by n. The measure of an angle of a regular polygon is always that. Okay. If I wanted to figure out what the measure of an angle, what each angle is in a decagon, well, how many sides is a decagon? A regular decagon. How many sides is a decagon? 10. Okay. So that means your formula would be n minus 2 times 180 divided by n. Well, n is 10. Your calculator has a fraction button, a fraction bar. You can literally put in the way it looks. That's why we always write it out. Parentheses, 10 minus 2 times 180 over 10. You can type it in your calculator just like that, and it'll do the work for you. Each angle is 124 every time. Not too bad. You don't have to draw these, but if you guys, we've done this one too. If this is an interior angle, what's that one? It's a what? Exterior. Each polygon has either an interior or an exterior angle. How many degrees does it take you to get from here to here? 360. How many degrees does it take you to get from here to here? 60. How many degrees does it take you to get from here to there? They're all 360. Exactly. You're like, just stop doing it, Murphy. What happens here is you get the sum of exterior angles is always 360. The sum of exterior angles is always 360. This one is really useful. No matter what, the sum of the outside angles will always equal 360. Which means, we go back to the idea, if I have a hexagon, for example, how many interior angles are there? 6, which means how many exterior angles are there? 6. If this is a regular polygon, what's the relationship between those two angles? No. Those two angles won't be equal. They have to equal 80. Correct. And that's the idea here. Each exterior angle has a supplement, the interior. An interior angle plus an exterior is always 180. They're supplementary. Right. Now, go back to the idea of regular polygons again. Regular polygons have all sides, all angles congruent. Now, excuse me, if all the angles are the same on the inside, doesn't that mean all their outside angles also have to be the same? So what happens is, we can do this one little shortcut. How many sides or angles are in a, in this case, we have a hexagon. We have what, 6? If I wanted to figure out what the exterior angle was, what do all 6 of those have to equal? What do all 6 of those have to add up to equal? 360. So to figure out the measure of an exterior angle in a regular polygon, this is really, really helpful, is always 360 divided by the number of sides. That's a hexagon, that's why. Yeah. So in a hexagon, it's got 6 sides. What's 360 divided by 6? What's 36 divided by 6? 6. Add a 0, you get 60. So the outside angle is 60, which means the inside angle is 120. It's a lot more math, isn't it? It's always easier to work outside in with regular polygons. Always, always, always easier to work with the outside angles. Because you know the sum of the exterior is always 360. And the measure of an exterior angle in a regular polygon is always 360 divided by n. The interior is just the sum. It'll always, always, always work. Right. Which means you can answer questions. Oops, ahead here. Where was it? Actually, we'll do this one first. Now, don't draw this, but I'm trying to figure out what angle y equals. first of all, is this a regular polygon or just a normal run-of-the-mill polygon? It's just a normal polygon. How many sides or angles does it have? 5. Count the letters, which is 5 vertices. Okay? Which means, if I'm trying to figure out what the measure of angle y is, well, all I know that if I take all 5 of them, what do they all have to add up to equal? Well, we're on the inside here. Sum of the interior is always the number of sides minus 2 times 180. How many sides are there? 5. So I know that 5 minus 2 times 180 is 540. So all 5 of those angles have to add up to equal, well, what's angle O? Just turn it into a simple algebra problem. Add and subtract, exactly. Add them all up and subtract them. And solve for the angle y. I think you just said it, didn't you? You got 70 when you did it? Right. That's what you're doing. You're using the sum of the interior. There's only a couple of different ways of setting it up. It's just a matter of what can you show. Well, I know that I've got 5 interior angles. I know that all 5 would have to add up to equal 540. Solve the missing value. Okay. All right, that's kind of what we're doing today. Find the missing angle. Also goes along with something like this. Oops, got ahead of myself here. The measures of the exterior angles in a convex, convex, concave. You guys know the difference? For polygons? Convex is just your is a normal looking one. Concave, if it's a concave polygon, you have 5 sides. That would be concave because one side is moving inward. Yeah. Convex is all the sides are on the outside. Nothing's moving outward. Everything's moving outward. That's the difference. Normally we deal with convex. Measures of the exterior angles in a convex pentagon. 2x, 4x, 6x, 8x, and 10x. Are you working with inside angles or outside angles? Well, outside angles always have to add to equal 360. So this is quite literally 2x plus 4x, 6x, 8x, 10x, and it has to equal. Yep, that's all you're doing. That's all you're doing. In this case, though, it's not 24. It would be 30. So 2 and 8, 10, 4 and 6 is 10, so you have 30x. Divide that out, and you got what, 12? Now the value of x is 12, and then it asks you, what's going to be the smallest angle? And the 2x has to be the smallest, because it's got the smallest scalar. So 2 times 12 is? That's where you're getting the 24. What's up? It's going to be the smallest, but you got to figure out what the value of x is to figure out what the measure of the smallest angle is. So your multiplier here, you have angles of 24, 48, what is that, 72, 96, and 120. Those would be the 5 angles in that pentagon if you drew it out below. That's where that's coming from. All right. So find the measure of an interior and an exterior angle in a regular polygon. Well, first of all, do you guys all agree that somewhere in a polygon, 3 sides will always run into each other, no matter what? So what I like to do is stuff like this. What I'm doing here is I'm showing where you have interior and exterior angles. We just did hexagon. Let's do the decagon. How many sides are in a decagon? 10. So if I'm looking at a regular decagon, I want to find the measure of an interior and an exterior angle. That means my number of sides is 10. What's easier to find first, outside or inside? Outside. Always work with the outside angle, especially with regular. Because regular polygon on the outside angle is 360 divided by n. Well, what's 360 divided by 10? What's the supplement to 36? Press some buttons in the calculator. 180 subtract 36, and you get. That's how fast this is. No matter which one are you working with. Are you working with an outside angle? Is it easier with the outside or the inside? Yes, sir. They're supplementary. 36, take 180 and subtract 36. Yeah, inside and outside angles, interior and exterior, always add it to 180, no matter what. All right, same idea. 15 gon has how many sides? 15. But somewhere along those 15 sides, 3 of them have to be connected, right? Work with the outside. What's 360 divided by 15? You guys have calculators. Take a calculator. So if the outside angle is 24, what's the inside angle? There you go. This is really, really, really fast stuff. Which is really, if you think about it, 4 scenarios really, not that much. I think the weird one is this. Yeah. An interior angle, I don't want to do this, we'll just do that one, is 135. How many sides does it have? Go back to the idea, it's a regular polygon. You have an interior angle of 135. Now, if 135 is the inside angle, what's the outside? Okay, what do you get? You have 45, right? Now, go to the idea here, go back to this one here. The exterior angle of a regular polygon is 360 divided by n, number of sides. Exterior angle is 360 divided by n. If I take the exterior angle divided by 1, does it change the problem? No. Before we do this, do you guys agree that this is a true statement? Okay. Is this a true statement? Yeah. What did I do? I switched them on the diagonal. Anytime you have fraction equal fraction, you can move things on the diagonals and still get a true statement. It's called exchange-o, change-o. Okay? It's called exchange-o, change-o. Anytime you have fraction equal fraction, you can switch things along the diagonal, which means if I take an exchange-o, change-o of those two, I get the number of sides is 360 divided by the exterior angle. What's 360 divided by 45? 8. There you go. It's always easier to work with the exterior angles going through them. So remember, the number of sides is 360 divided by the measure of an exterior angle of a regular polygon. Always works. We did this problem a minute ago where we did 144s. If 144 is on the inside. What was on the outside? Remember? We just did this problem. It was what, 36? Okay. What's 360 divided by 36? Didn't we just do that problem a minute ago about that together? Which is 10, not 12. Okay. We just did that. That's why this works. Okay. That's why it works. It's always easier to work with an outside angle than it is inside. Interior angle is 108. If the interior angle is 108, what's the outside angle? 72. So, how many sides is that? 5. Okay. Always easy to work with the outside angles. You always hear me say work outside in if you need to. They got 180 crazy with the rest to start with. Okay. We got a textbook up here if you want to take a picture. This is really fast stuff. All right. Trust me, you're going to want to make sure you have those formulas written down on your page so you can go back and reference them. We'll use them over and over and over and over again.